I'll go through some more problems, and the first one is pretty straightforward. The question is, in the same circle or congruent circles, congruent central angles have congruent arcs. And the, if you recall the definition of the size of an angle in radians, then it should be pretty clear, because what we say is that an angle theta is equal to the arc length, which I'll call L, divided by the radius. So congruent circles have the same radius, and that means that they're basically, we have the definition says that the size of the angle is directly related to the size of the length of the arc. In fact, we refer to the arc, or the size of the arc, using the angle. So this is just a straightforward application of the definition of what an arc and angle are. Okay, let's look at the next question. It's a bit more interesting here. And that is, here we have a circle, and the circle has a radius of 5, as shown here. And this is the diameter of the circle, and the diameter of the circle it forms perpendicular with this chord here. And so we want to find the length of the segment x. Well, a couple things right off the bat is, if the distance from this point to the edge of the circle is a radius, then this whole length must be 5, which of course tells us that this is 3. Okay, something else we can do is we can form add this line here. Oh, that's not doing it. So we add this line here from here to here, and this line from here to here, like that. Remember, this is a right angle. So we have a right triangle, and we know that the length of this line here is 5. So the length of this line is 5, and the length of this line here is 5. So the right triangle, here's our two congruent sides, 5 and 5. Here's a common side. So that says that this triangle here and this triangle here are congruent triangles. So we have that this angle, this length of line right here, is also equal to x. Okay, so both sides are equal to x. And we have that this length is 3. We have the hypotenuse is 5. So you may recognize this as a 3, 4, 5 right triangle. So without even using the Pythagorean theorem directly, just recognizing that this is a 3, 4, 5 triangle, we say that x equals 4. So that's the solution to that problem. One more. Here we go. Okay, we have tangent AD here. We have diameter DC right here. Center of the circle is O. The question is, which set of congruent angles can be used to prove the triangle ADC, the big triangle, is similar to the triangle DBC. So we want to show that the smaller triangle here is congruent to the larger triangle. Well, a couple things we know right off the bat. For instance, because this is a tangent and this here to here is a radius, we know that this is a right triangle. And because this triangle right here, this smaller one, is inscribed in this circle, we know that this is a right triangle because it's inscribed in a semicircle. So we have we have that both of these, this triangle and the larger triangle, are right triangles. So all we would need to show is that angle 1 right here, this angle right here, angle 1 and angle 3 are the same. And if we show that, or equivalently, if we show that angle 2, or angle 2 here, and angle 6 are the same, that works. So by the way the triangles are labeled, we have two right triangles. So I want to answer this question saying, because we have right triangles, if angle 2 and angle 6, we can show those two angles are the same. Then we can show that the two triangles are similar. Okay? So until next time.